Hello everybody, welcome into another lesson. So today we are going to talk about transforming formulas. So basically, your formulas you may know, such as this one here, C equals 2 pi r, that's the circumference of a circle, review from pre-algebra and basic math. Well, you can manipulate those formulas to find another variable. So let's say you actually knew the circumference, and we know what 2 and pi are, but you don't know the radius. You can manipulate the formula to find the radius, which we're going to do for this. We're going to find r. What we want to do is isolate r by itself on the right hand side. We have 2 pi r, so we need to take that 2 pi r and divide by 2 pi. And then what you do to the right, you got to do to the left, so you got to take that circumference and divide it by 2 pi. Well, the right side, you'll have 2 pi and 2 pi canceling out. On the left side, you'll still have the circumference over 2 pi. Nothing cancels out of that. You'll set that equal to r. So r, the radius, is equal to the circumference c divided by 2 pi. That's the answer you would end up getting to solve for r. And I got more examples here. There's another formula some of you may recognize. F equals ma. Force equals mass times acceleration. And they want us to solve for a, the acceleration. So I'll write that here. For the duration of this lesson, if you see a red semicolon and the letter in red, that's the letter we're solving for. So, okay, we have ma on the right hand side. We want to solve for a. Well, we want to get the a by itself. We need to take ma. We need to divide that by m. But what you do to one side, you got to do to the other. You got to take that f and divide it by m. The right side, your m's will cancel out. The left side, you'll have f over m. That'll be equal to a. So the answer is a equals f over m. We found the solution, force over mass. Alright, let's see. S. That's not how I want to write S. It looks too much like a 5 if I do that. S equals V over R. Okay. We want to solve for R. So S equals V over R. We want to solve for R. This case, we have R in the denominator. We need to get that r out of the denominator. So what you want to do is on the right side, take your v over r, multiply that times r. But what you do to one side, you got to do to the other. You'll take your s times r. So on the right side, the r's will cancel out. The left side, you'll have rs. S times R is simply RS. That'll be equal to V. Well, we have RS, we want to just solve for R. What you have to do, since we have RS, we want to just solve for R, you got to divide both sides by S. So the left side, the S's will cancel out. You're just left with R is equal to V over S. So R equals V over S. All right. Let's see, I think we get that formula. Let's see, how about A equals P plus PRT? we want to solve for the variable t. We want to solve for t. Well, what you'll want to do is isolate the t term by itself. That PRT, since those are multiples of t, you'll want to isolate that by itself. So what you got to do is take this p plus PRT. You want to subtract the p from that to get rid of the p and just get PRT by itself. But what you do to one side, of course, you must do to the other. So you'll take a minus p on the left. So the left side, you'll have a minus p. The right side simplifies into PRT. Well, we want to solve for just t. We have PRT. We need to divide both sides by PR in order to get t by itself. So we'll divide both sides by PR. The left sides, the PRs will cancel out. Left side, you'll have a minus p all over PR. The right side, you just have t. So t equals a minus p all over PR. Yeah, it's very useful to manipulate formulas because when we get to geometry, you're going to have some problems that you already know the surface area, you already know the volume or the area of something or even the perimeter, but you need to find a missing length or width or height or something like that. And you're going to have to be able to manipulate the formula to get that. Alright. Here's a useful one. The formula from converting Fahrenheit to Celsius. Celsius equals 5/9 times Fahrenheit minus 32. So you got the formula to convert Fahrenheit to Celsius. We want to solve for Fahrenheit. So what they want us to do really is convert this to Celsius to Fahrenheit. They want to switch it around. You can manipulate the formula to solve for F. You want to solve for F. So what you got to do, you have 5/9 times the quantity of F minus 32. You want to get that F minus 32 by itself. Well, you need to take that 5/9, you need to multiply that by 9/5. You multiply it by the reciprocal. So multiply your 5/9 by the reciprocal, 9/5. So you take 9/5 times 5/9 times the quantity of F minus 32. But what you do to one side, you got to do to the other. 9/5 times C is just 9/5 C. Okay. Well, the right side, your 5s and your 9s cancel out. Those just become 1. You got 9/5 Celsius is equal to Fahrenheit minus 32. Well, we have Fahrenheit minus 32. We have the F minus 32. We just want to solve for F. You have minus 32. You need to add 32. If we do that, we add 32 to the right side, you'll just get Fahrenheit by itself, the F by itself, but you got to do it to the left side also, so you would end up having 9/5 C plus 32. And that is the formula for converting Celsius to Fahrenheit. 9/5 times the Celsius plus 32 is equal to your degrees Fahrenheit. So we went from converting Fahrenheit to Celsius to Fahrenheit. We switched it around. So being able to manipulate formulas will not only help you in math, it'll help you in chemistry and physics and sure in some biology courses, geology, meteorology, astronomy, so on. It'll help you in all kinds of courses. So that's another reason we're learning this. Alright, let's see. We have v squared equals u squared plus 2as. V squared equals u squared plus 2as, solve for s. We want to solve for s. So, what you got to do then, you want to get that 2as term by itself first, which means you're going to take that u squared plus the 2as, then you'll subtract u squared, but what you do to one side, you got to do to the other. You'll take the v squared minus u squared, so the left side you'll still have v squared minus u squared. That'll be equal to just the 2as once you simplify it. Okay, well, we have 2as, we want to solve for just s. We want to do that, we got to just divide both sides by 2a. So on the left side, your 2a's will cancel out. So on the right side, you'll just be left with s. The left side, you'll have v squared minus u squared over 2a, since nothing cancels out on the left. So s, therefore, is equal to v squared minus u squared all over 2a. All right. Let's see, capital S. Nah, I don't want to. I hate doing that. I don't like writing S's. They look like a 5. Here's a good one. F equals FG all over F plus G minus D. And they want you to solve for D. So we got to solve for D. Well, your D term, this whole thing, F plus G minus D, that's in the denominator. We want to get rid of that denominator first. If your term that you're seeking is ever in the denominator, first find a way to get it out of there. What you're going to have to do on the right side is take your FG all over that F plus G minus D, take that times the quantity of F plus G minus D, basically multiply by the reciprocal, but have a denominator of 1. You'll see that the F plus G minus D's cancel out, but you got to do it to the left side, so you'll take the F times F plus G minus D, which now on the right side, all you have is FG. If I were you, because we want to get D by itself ultimately, go ahead and distribute that big F. So you'll take big F times little f plus big F times G minus big F times D. All right. Now, we want to get that negative FD by itself, right? What you'll want to do is subtract FF and FG from the left side. So we do that, you'll get negative FD. What you do to the left side, you got to do to the right. You would get lowercase fg minus uppercase f lowercase f minus uppercase f lowercase g. Alright, now we just want to solve for d, so you got to divide both sides by negative f. So on the left side, the negative f's will cancel out. You'll just be left with d is equal to that fg minus ff minus fg all over negative f. Well, we can pull that negative into the numerator. It's usually good to have the negative in the numerator instead of the denominator. So d would equal negative of the quantity of fg minus ff minus fg all over f. That's the answer you should get for D. So what I did here first, I'll break it down. Get your f plus g minus d out of the denominator. Find a way to get rid of the denominator altogether if you can, especially if your term is in the denominator. Of course, you just multiply by the term that's in the denominator. You just simply multiply it by that, and they'll cancel out. What you do to one side, you do to the other. The right side, I ended up being left with lowercase fg. I ended up distributing the uppercase f to the terms on the left-hand side. Then I divided both sides. I subtracted both sides, ff minus fg. Ended up with negative fd on the left, ended up with fg minus ff minus fg on the right, divided both sides by negative f, and got this answer: d equals negative of the quantity of fg minus ff minus fg all over f. Yes, I got more like it. Alright. I think we'll do one more here. It's going to be the same problem again, only it's a little bit different, because we're going to solve for a different variable. Alright, we have the same problem again, fg all over f plus g minus d, only this time we're solving for lowercase f. Well, you're like, well, wait a second, just wait a second, what are we going to do with this? We have a lowercase f in both the numerator and denominator. That's okay. Try to get rid of that denominator first. Always try to get rid of that denominator first. Well, what we have to do is multiply once again the right side by f plus g minus d. You'll just end up getting fg by itself, but you got to do it to the left side too, so you take f times the quantity of f plus g minus d. If you do that, you'll get ff plus fg minus fd. That'd be equal to lowercase fg. Okay. If I were you, keep your lowercase f term on the left side. Try to get your lowercase fg term to the left side also. So what we're going to do is we're going to take ff plus that fg minus the fd, all those uppercase. We want to get the fg out of the right side, so that'll go to 0. So we got to subtract fg from the left side also. So you'll get uppercase f lowercase f plus uppercase f lowercase g minus uppercase fd minus lowercase fg equal to 0. Now we got the lowercase f's on the same side, because ultimately we're going to want to factor it out. Now if I were you, I'd move the uppercase fg and the uppercase fd over to the right side. if we subtract, actually let's move the FD over. We have negative FD on the left. If we add FD, we'll get rid of it. We'll have uppercase F, lowercase f, plus uppercase F, lowercase g. Then if you add positive FD, that goes away. You'll just have minus FG. That'll equal, because you got to add the FD to the right, you'll get FD on the right hand side. Okay. Now, what we have here, we want to get rid of that uppercase FG also. So to get rid of that out of the left hand side, you got to subtract it. You end up just getting uppercase F, lowercase f, minus lowercase fg. That'll be equal to, since we subtracted fg from the left, you got to do it to the right. You'll get fd minus fg. Alright, so now we got the lowercase f's on the left hand side, which is exactly what we want. Well, we can factor out both terms, the uppercase f, lowercase f, and the lowercase fg have a common lowercase f, right? We have a lowercase f, factor that out. The first term would just be times uppercase f, because f times f is ff, minus, you just got g in the parentheses. Because if you do that, you'll get minus fg. So basically, when you factor, a short lesson on factoring, look for what both terms have in common. Factor it outside of the parentheses, and then whatever remains after you factor it out is what you multiply it by. So you'll get lowercase f times the quantity of uppercase f minus g equal to fd minus fg. Now, I just want to get the lowercase f by itself. I have f times the quantity of f minus g. I need to divide both sides by the quantity of f minus g. If I do that on the left, I'll just get f. Do that on the right, you'll get fd minus fg all over the quantity of f minus g. So lowercase f is going to be equal to uppercase fd minus uppercase fg all over the quantity of uppercase f minus g. So these formulas can get very hairy very quickly if you're trying to isolate certain variables and solve for them. But a general rule, if you're trying to solve for one variable, you almost treat the other variables like constants, like numbers. That's the best way to do it. Basically, you solve for one variable, treat that as the variable, the rest you just basically treat like numbers. And then you just perform your multiplication, division, addition, subtraction. And if you have a term that you're seeking, the one you're trying to solve for, if it's in the denominator, get it out of the denominator. Just try to get it out of the denominator altogether. So that's been it for transforming formulas. Next lesson, we are going to divide monomials. We've multiplied them. Up till now, we haven't divided them, but we're going to in the next lesson. So I hope everyone has a good night. Take care.